Today I'm going to talk about definite integration. Definite integration is a fundamental concept in calculus. By using definite integration, we can solve many complicated problems in physics, in engineering, in economics, and every part of science. By using definite integration, we can easily obtain areas and volumes. By using definite integration, we can simplify many complicated concepts and we can find out their values very easily. In today's episode, I'm going to talk about what exactly the definite integration is. I have divided this tutorial in terms of episodes. This is first episode. In this episode, I'm going to talk about what is exactly the definite integration is. And in coming episode, consequently, I shall be solving more difficult problems. So let's start today's topic, that is definite integration. Definite integration is the next step of integration. This is the symbol of definite integration where we write the limits here below the symbol and above the symbol. The value we write below the symbol is called lower limit of definite integration, and the symbol or the number we write above is called upper limit of definite integration. And here we do write function f of x with respect to x. For an example, integration of sin x with respect to x, and the limits are 0 to pi by 2. 0 is called lower limit and pi by 2 is called upper limit. One more example, integration of x square plus 2x plus 3 upon x plus 1 with respect to x, and limits are 0 to 5. So even it is a question of definite integration because it is involving lower limit. This is 0 is lower limit and 5 is upper limit. So any integration involving limits is called a question of definite integration. Now let us talk about steps to solve the questions of definite integration. Suppose we are given a question to evaluate integration of f of x with respect to x for limit a to b. So what are the steps? Step 1. Let integration of f of x with respect to x equals to phi of x. Step 2. Let integration a to b f of x dx equals to, here we write a box, a square bracket, I call it as a box. So, and the limits are written right side of the box. The lower limit is written down and upper limit written up. And the result of integration, that is phi of x, is written inside the square bracket. After that, we do find the phi of b and subtract the value of phi of a. So phi of b minus phi of a. Therefore, integration of f of x with respect to x for limit a to b is equals to phi of b minus phi of a. To understand this idea, let us take one practical example. Example 1. Evaluate integration of x square plus 2x plus 1 with respect to x from 0 to 1. Step 1. Integration of x square plus 2x plus 1 with respect to x equals to x cube by 3 plus 2x square by 2 plus x. 2 get cancelled. I have not written plus c as usually we write. Let x cube upon 3 plus x square plus x equals to phi of x. Step 2. Therefore, integration of x square plus 2x plus 1 with respect to x from limit 0 to 1 equals to, now we write the box here, and inside this box we write phi of x and write down the limits here 0 to 1. So we have phi of x equals to x cube by 3 plus x square plus x. Now integration of 0 to 1 x square plus 2x plus 1 with respect to x equals to phi of 1 minus phi of 0, that is upper limit value minus lower limit value for function phi of x. We have phi of x equals to x cube upon 3 plus x square plus x. Now the value for function phi of x with x equals to 1. So phi of 1 equals to 1 by 3 plus 1 plus 1. 1 plus 1 by 3 plus 2, that is 1 plus 6 by 3 equals to 7 upon 3. Similarly, phi of 0 equals to 0 plus 0 plus 0 equals to 0. Therefore, now we put the values of phi of 1. Phi of 1 nothing but 7 upon 3. Phi of 0 is 0. We put the values here. So phi of 1 is 3. Phi of 0 is 0. Therefore, integration 0 to 1 x square plus 2x plus 1 with respect to x equals to 7 upon 3. Example 2. Evaluate integration of 1 upon root x with respect to x for limit 1 to 2. Solution. We have integration of 1 upon root x with respect to x equals to integration of x raised to minus 1 upon 2 with respect to x equals to x raised to minus 1 upon 2 plus 1 divided by minus 1 upon 2 plus 1, that is equals to x raised to 1 by 2 upon 1 by 2, that is 2 into x raised to 1 by 2 equals to 2 root x. Now step 1 is over. Let 2 root x equals to phi of x. Therefore, integration of 1 upon root x with respect to x for limit 1 to 2 equals to, here we write the box, inside the box we write phi of x and write down lower limit here and upper limit here, that is equals to phi of 2 minus phi of 1. We have phi of x equals to 2 root x. Therefore, phi of 2 equals to 2 root 2 and phi of 1 equals to 2 root 1 equals to 2. Therefore, integration of 1 upon root x with respect to x from limit 1 to 2 with respect to x equals to 2 root 2 minus 2, that is 2 common root 2 minus 1. This is required solution. Example 3. Evaluate integration of sin x with respect to x for limit 0 to pi upon 4. Solution. Step 1. Integration sin x with respect to x equals to minus cos x. Here I have not written plus c. Let step 2. Let minus cos x equals to phi of x. Therefore, integration of sin x with respect to x from 0 to pi by 4 equals to, here we write the box, inside the box phi of x, and here lower limit and upper limit. We have phi of x equals to minus cos x. We first find out phi of pi upon 4 equals to minus cos pi upon 4 equals to minus 1 upon root 2, and phi of 0 equals to minus cos 0 equals to minus 1. Therefore, phi of x 0 to pi by 4 equals to phi of pi by 4 minus phi of 1 equals to minus 1 upon root 2, and this is minus formula, and value of phi upon 0, here it is 0. Phi of 0 is equals to minus 1. Now simplifying, that is minus 1 upon root 2 plus 1 equals to 1 minus 1 upon root 2 equals to root 2 minus 1 upon root 2. Therefore, integration 0 to pi by 4 sin x with respect to x equals to root 2 minus 1 upon root 2 is required solution. Example 4. Evaluate integration 1 upon phi x plus 6 with respect to x from 2 to 3. We can also read it as integration 2 to 3 1 upon phi x plus 6 with respect to x. But I commonly read as integration of 1 upon phi x plus 6 with respect to x for limit 2 to 3. Solution. Step 1. Integration of 1 upon pi x plus 6 with respect to x. We know the formula. Integration of 1 upon ax plus b with respect to x equals to log of modulus ax plus b upon a. Therefore, integration of 1 upon phi x plus 6 with respect to x equals to log of modulus phi x plus 6 upon 5. Now, let log of modulus phi x plus 6 upon 5 equals to phi of x. Therefore, integration from limit 2 to 3 1 upon phi x plus 6 with respect to x equals to box, and here phi of x, and the limits are 2 to 3, that is equals to phi of 3 minus phi of 2. Since phi of x equals to log of phi x plus 6 upon 5, therefore phi of 3 equals to log of phi into 3 plus 6 upon 5 equals to log 15 plus 6 upon 5 equals to log 21 upon 5. Now we need to find phi of 2. Phi of 2 equals to log of pi into 2 plus 6 upon 5 equals to log 10 plus 6 upon 5 equals to log 16 upon 5. Therefore, integration of 1 upon pi x plus 6 for limits 2 to 3 with respect to x equals to log 21 upon 5 minus log 16 upon 5. You see, log pi of 2 is equals to log 16 upon 5. Now 1 upon 5 is taken common. So log 21 minus log 16 equals to log 21 upon 16. 1 upon 5 into log of 21 upon 16 is required solution. In episode 2, I am going to talk about more tough problems, more difficult problems, and more advanced problems compared to this episode. So, be in touch with me for the next episode. Till then, wish you good luck. I hope before meeting for episode 2, you will be thorough with episode 1. Then only episode 2 will be much useful to you. Meet you again with the next episode. Till then, wish you good luck. Before saying goodbye to you, I would like to request you like, share and subscribe the channel to remain updated. Wish you good luck. All the best.